If I look at coding, programming, which is one area where AI is making the most progress, what we're finding is that we're 3 to 6 months from a world where AI is writing 90% of the code. And then in 12 months, we may be in a world where AI is writing essentially all of the code. This is a direct quote from Anthropic CEO Dario Amodei, and he is basically touting the benefits of generative AI and essentially equating it with some form of complete automatic coding or artificial intelligence. And I wanted to completely debunk this false claim. So first up, this is a terminology misdirection. Writing a code is not the same as using a tool. So this is a category error. If we take a look at framing this AI writing code, this is a fundamental category error because it conflates autonomous creation with tool-assisted composition, right? This is a huge problem. Also, we have the tool-user relationship. With AI coding assistants, they function as a sophisticated autocomplete system, and the human is part of that creative process. So the idea that AI is writing the code is like saying Microsoft Word writes novels, or the k-means clustering is automating the financial assistance at a Fidelity or Schwab. If you look at the cognitive architecture next, large language models operate as a prediction engine. There is no intentionality, planning capabilities, or causal understanding required for true writing. It's just an amplification of the human cognitive process rather than replacing it. And then we have the orchestration reality, in that humans are orchestrating these solution architectures. They're asking for the requirements, they're evaluating the output quality, and they're integrating the components. AI is accelerating the implementation phase only. It's like saying, I have a kazoo, so because I have a kazoo, all music will be automated. No, a kazoo can play music that's very unsophisticated, and it makes it really simple to play a tune. That doesn't mean it's automating the act of creating music and composition. And so this attribution inversion is really at the core of the problem. And what we see here is that the phrase AI writes code is actually inverting the causality. Humans are the primary creative agents using AI, and it's just a specialized product where it can amplify your current capabilities, just like a search engine or an IDE or a compiler, etc. So let's go ahead and get into some of the technical details about why this is such a poor phrasing and poor analogy. First up, AI coding is pattern matching in vector space. And so this is a fundamental limitation. Large language models perform sophisticated pattern matching, but not for reasoning in terms of semantic reasoning. This is like claiming k-means clustering could replace financial advisors, right? It's just finding a pattern in multidimensional space, an X, a Y, and a Z. For example, age, weight, and height. If you put them together, you'd find different kinds of athletes. That doesn't mean that you can automatically determine all of the different clusters without having a human there to label them. Likewise, if we look at the verification capabilities, AI cannot independently verify the correctness of generated code. It approximates solutions based on statistical patterns. So approximate is not good enough with coding. A great example would be infrastructure as code. So if you ask any tool to generate infrastructure as code, there are subtle problems that crop up. Now, it's very helpful, just like an IDE is very helpful, or a modern compiled language that uses things like ownership with Rust. These are very helpful, but there's a big difference between helpful and full automation. And this is really the problem, is that if you leave a vulnerability, or you need to go through 7 or 9 or 20 iterations on the code, that's the real issue, is that you have no verification capability. We also have the problem of hallucinations with things like GitHub Copilot and similar tools, or Anthropic, which is pretty good. They still fabricate non-existent APIs, libraries, function signatures. This is not going away. And so you need, again, a human to validate it. It seems simple with a toy problem where the training set has all of the data. But again, it's a fantasy to say that in a year, all of the code will be written by generative AI systems, because how could you possibly say that in the future all of the different libraries or all of the different things you need to code or new problems that get developed are automatically going to be handled by this coding assistant when it doesn't yet know what those are, right? They're future things that would be invented. We also have this idea of consistency boundary. So the performance is going to degrade with code base size and complexity, and also with cross-module dependencies. So we see this real problem with large language models, and I've seen it myself, where once you get to a certain size of a project, now you have to put more and more context into a coding assistant, and it's going to get worse at giving you recommendations, and especially if you need to integrate with a larger code base. So if you have, in many cases, a production code base that's, let's say, hundreds of thousands of lines of code, how could it possibly read that in when the context size won't even support it, right? It doesn't make sense. And so this consistency is really an issue where, again, a human has to be involved. It doesn't mean that, again, an IDE that can talk to different code bases is not helpful. Of course it is. Similarly, just because you're using a tool, it doesn't mean that that tool is now replacing the aspect of human coding. We also have the novel problems gap, where in terms of large language models, in some particular common patterns, they could perform at near human level. For example, generate a unit test or generate some boilerplate YAML code or something, but they could fail catastrophically on a novel problem because they don't have that training data. So we see this with full self-driving as well. When there's a new pattern that's never seen, like a semi-truck is flipped on the road and it's sideways, all of a sudden the car accelerates into the truck, which has happened with Teslas. Now we have the last mile problem, which I think is one of the more interesting problems that is completely ignored by the statement from the CEO. And maybe because he's never been a professional software engineer, he's saying something like this, but the integration is the problem. And this is why they invented terms like DevOps, which is the idea of, continuous integration, continuous improvement, is that there are significant manual interventions needed for AI generated code in production environments. We don't have the exact numbers of this, but again, the CDK is a pretty good example of this, or infrastructure as code. If you generate infrastructure as code, and then it turns out that they left a security hole open, or maybe it's too aggressive and it closes a security port that you need. For example, one service needs to talk to another service. You push that change into production. It turns out that, hey, wait a second, these two services used to talk to each other, but now they don't talk to each other. Now it could take 3 days to debug what the problem is because AI made this very subtle change that a human wouldn't have made. So the integration is very significant. And this is the problem with people making claims where they're not experts in the domain, is that the details do matter. We also have the concept of security vulnerabilities. And there is evidence that some of the code that's generated could introduce more security issues than human code. And especially if you're using languages that have by themselves not a good security model, like C or Python, where in many cases you can do things like in Python, for example, you can have variables that constantly get replaced. Now, if you use more modern languages, like modern compiled languages like Rust, where they have very good security models, that might be less of an issue, but it also could depend on the language. We also have the requirement specification. So AI cannot translate these ambiguous business requirements into precise specifications. So this is a real issue in just regular software engineering. Is you listen to a product manager, they tell you something, the software developer builds something that's totally different. This problem is even further amplified because if someone that's non-technical is giving the requirements out, they may not understand like big O notation, or they may not understand security. How could they possibly ask the right question to generate the right requirements? We also have the testing complexity. And so AI could maybe build really simple tests, but do they have the context of experience and wisdom? Have they seen production systems fail? Of course they cannot do this because they have no understanding of the real world. They're just pattern matching systems. And then we have the infrastructure context as well, which I alluded to, is that AI doesn't understand the concept of DevOps or CI/CD pipelines or infrastructure constraints. It's just pattern matching system. How could it possibly understand all the different edge cases and doing continuous improvement? It's just finding patterns. So this is where really things get into the weeds, and there could be substantial systemic problems with infrastructure. Now, in terms of the economics and competition realities, now let's talk a little bit differently about why programmers may not be in trouble, but the generative AI companies may be in trouble. So it's maybe more likely that in a year, AI companies could be going out of business. And here's why I'm going to dive into the details here. So first up, we have open source itself. We see the history of computing shows full commoditization of critical infrastructure. Linux is dominant in terms of operating system, 90% global market share. We see open source languages, something like 95% plus of the top 30 languages are open source languages. We see Postgres, MySQL, they dominate in terms of databases because they're open source. Git, open source versus things like proprietary Perforce source control. So the history of computing shows that always open source dominates because it's good enough and it's completely open source. So it means that people can make changes to it. So it's very unlikely that this is going to break the mold. There's no evidence that the closed source models like Anthropic Claude or OpenAI's ChatGPT will be the leader. In fact, we're seeing the opposite. We're seeing open source starting to exceed the capabilities with things like DeepSeek R1. We also have the concept of zero marginal cost. So the economics of AI generated code is approaching zero. So this means that there is no sustainable competitive advantage for closed source models, right? So if everybody can do the same thing, how could you possibly charge for it? We also have the negative unit economics. So commercial LLMs provide solutions that are actually operating at a loss per query for complex coding tasks. So this means that every one of these inference tasks for a high token generation, let's say 8,000, 10,000 token generation, is going to exceed the subscription pricing, which by itself creates unsustainable unit economics. So if you're operating at a loss, but a person at home can operate it for free because they have a GPU, how is it possible that you can actually stay in business? We also have the human value shift, right, where the value is starting to concentrate in requirements gathering, systems architecture, domain expertise, and all of these are resistant to AI automation because, first of all, AI is a bad term. It's just pattern matching in vector space. We also see this rising open competition. So open models like Llama, Mistral, CodeLlama, right? They're approaching the closed source solutions at a fraction of the cost. In fact, free in the case of running it at your local machine. So this is full commodity competition. And then let's get into the false analogy of a tool versus a replacement. This is really where I think we can debunk this argument by the CEO of Anthropic, is that the tool evolution pattern. So Genai coding tools are following a historical pattern of developer productivity enhancements. Like, for example, we used to have Vim only, and Vim is very difficult, or Emacs, right? These are very complex tools to learn. But then we started to get more and more advanced IDEs with code completion that can compile code, they can integrate with different version control systems. And then we have the enhancements with version control itself, right? We used to use these really clunky version control systems, and then there was SVN, and then they got to Git, right? So we have an improvement in tools. Also, DevOps and CI/CD pipelines were not mainstream for a lot of my career, but these just amplify rather than replace developers and increase the speed and productivity. So if you think about it, it's really a productivity amplification. And you can see that it's a productivity gain that is really what we're seeing. It's enhancing the developers, not replacing them. Just like an IDE doesn't replace a developer, it's nonsense. And then if we look at the cognitive offloading, the AI coding tools could offload really simple problems like, hey, generate a unit test for me, or generate this YAML file for me. But then it allows the engineer to focus on really deep technical problems like, hey, what are the edge cases when I deploy this to production? Like, what is the load of the system, under these certain conditions? Like, how do I make the system more efficient? How can I convert it from Python to Rust, right? This is similar to like a calculator, how it could be used to transform mathematics. It doesn't mean the human's not evolved. You still have to punch the things into the calculator. And we also have the decision boundaries as well. So the majority of critical software engineering systems remain outside of the GenAI capabilities. So requirements analysis, architectural trade-offs, integration strategies, compiling the code, pushing the code to production, checking it in. And so we see that, in fact, it's just yet another tool that's going to help people be productive. And then finally, if we look at the historical precedent, even though we've had lots of automation over the last 50 years, you can see that the development tools consistently augment rather than replace developers. Compiler automation, visual programming, low-code platform. We keep seeing that, in fact, there's a logarithmic enhancement, right? So once you get into getting a new tool, great, maybe you get a 10% gain, but at the heart of it, it's just making people that are really proficient more proficient. And so there's no evidence that AI is going to write the code for you, because AI doesn't even exist as a term. AI means artificial intelligence, but these are just pattern matching systems. In fact, you can write the code yourself to generate clusters with multi-dimensional space, or write your own vector database, right, which are some of the core components or similar components to large language models. It's complete nonsense to say that pattern matching is at the heart of automating developers' jobs. Now, the reason people may be saying these things, and I don't know the reasons for the Anthropic CEO, is there could be incredible pressure to get profitability or to get more users to the platform. And so oftentimes when people get this incredible pressure from investors, what they do is they just make things up, or they are making fantastical claims. Like, for example, if someone is catching you that the pace of automation is not at the level you'd like, you then just could double down and say, oh, well, not only is it going to be automated, but it'll do this and this and this. So this is a really common deflection pattern that people use, and also a way to confuse people as well. If you make a claim that a pattern matching system is the same as full automation, you're deliberately misleading people. And I think the thing I'll end on is really similar to saying that k-means clustering is useful, which it is. Like, for example, if I was able to analyze and find the best companies to invest in that have low price earnings ratio, but also have high growth rate in terms of profitability and have really good competition, and I did some k-means clustering operation, because I was able to do k-means clustering and I was able to determine the requirements, that doesn't mean that in the future you could programmatically always pick all different options to invest in, and that the systems would automatically invest in the right companies based on the right clusters, right? It's nonsense. It's the same thing with coding. Is just because you can do pattern matching, you can find some new tool that can help you do pattern matching, the human still has to make that executive decision. We see that with full self-driving as well. So it's that last mile problem that's the real problem. Of course, tools like generative AI could be used to generate a lot of code, but it's the human that's generating the code and asking the questions. And in fact, there is no reason why one company would be used versus another company. It's much more likely that, in fact, we could have a commodity environment where there's lots of different vendors and lots of different tools. And it's much more likely that the GenAI company itself will be automated. And I think that's what really we should think about is, when will GenAI companies be automated by open source?